Without the sun's heat and light, the Earth would quickly plunge into darkness and extreme cold. Temperatures would plummet rapidly, leading to the freezing of oceans, lakes, and rivers. Plant life, unable to photosynthesize without sunlight, would wither and die, disrupting the entire food chain. The loss of solar energy would also have a cascading effect on Earth's climate systems, triggering violent storms, hurricanes, and tornadoes as the planet's atmosphere attempts to balance the sudden shift in temperature. The absence of sunlight would disrupt the planet's water cycle, leading to widespread droughts in some regions and catastrophic floods in others. The sudden change in temperature and weather patterns would likely result in mass extinctions, with many species unable to adapt quickly enough to survive in the new harsh conditions. Furthermore, the loss of sunlight would have a significant impact on human civilization. With no source of heat or light, our cities would quickly become uninhabitable, plunging humanity into a struggle for survival. The global economy would collapse as agriculture, transportation, and communication systems grind to a halt. The lack of sunlight would also disrupt our circadian rhythms, leading to widespread sleep disorders and mental health issues. In conclusion, if the sun were to suddenly burn out, the immediate effects on Earth would be catastrophic, leading to a rapid and dramatic transformation of our planet and all life on it. This chilling scenario serves as a stark reminder of the fragile balance that sustains life on Earth and the profound impact that the sun has on our existence. Imagine a world where the sun has burnt out, leaving Earth in complete darkness. In this alternate history scenario, the fate of our planet and its inhabitants would be drastically different. Without the sun's light and heat, temperatures would plummet rapidly, making it almost impossible for life as we know it to survive. The Earth would quickly become a frozen, desolate wasteland, with no source of energy or warmth to sustain any form of life. As the sun's light fades away, the sky would gradually darken, and the once vibrant colors of nature would be replaced by a monochromatic world of shadows and darkness. Plants would wither and die without sunlight for photosynthesis, leading to a collapse in the food chain and mass extinction of animals that rely on plants for sustenance. Without the sun's gravitational pull to hold the planets in orbit, the Earth would eventually drift off into space, lost in the vast emptiness of the universe. The remaining human population, if any, would face a bleak and uncertain future, struggling to survive in a harsh and unforgiving environment. The process of the Earth becoming completely dark after the sun burnt out would happen relatively quickly in cosmic terms. Within a few weeks or months, the last remnants of sunlight would fade away, plunging our planet into eternal darkness. The once bustling cities and bustling landscapes would be shrouded in blackness, a stark reminder of the fragility and impermanence of life in the universe. In this grim and haunting vision of an Earth without sunlight, the concept of time would lose all meaning as the darkness envelops everything in its path. The end result would be a cold, lifeless world adrift in the void of space, a haunting reminder of the power and importance of the sun in sustaining life on our planet. Diving into the realm of alternate histories and what-if scenarios, let's ponder a fascinating question that takes us beyond the boundaries of conventional thinking. What temperature would Earth drop to in the absence of sunlight? Imagine a world where the life-giving rays of the sun suddenly vanish, leaving our planet in darkness. Without the sun's warmth to sustain us, temperatures on Earth would plummet rapidly. The atmosphere would cool down as heat is no longer being replenished, leading to a dramatic drop in temperature. In this chilling scenario, the Earth's surface would gradually lose its heat, causing widespread freezing and creating a harsh, unforgiving environment. As the days pass without sunlight, the temperature would continue to decrease, eventually reaching extreme lows that would make survival nearly impossible for most forms of life. Without the sun's energy to drive weather systems and maintain a balance of heat, the planet would become a frozen, desolate wasteland. In the absence of sunlight, the Earth's temperature would likely drop to well below freezing, plunging into sub-zero temperatures that would freeze oceans, solidify the ground, and blanket the world in ice and snow. The once vibrant and thriving planet we know would be transformed into a cold, dark world devoid of life as we know it. This chilling thought experiment serves as a stark reminder of the crucial role that the sun plays in sustaining life on Earth. It highlights the delicate balance of our planet's climate and the profound impact that even a temporary absence of sunlight could have on our world. As we ponder this what-if scenario, we are reminded of the fragility and interconnectedness of life on Earth, underscoring the importance of understanding and protecting our planet's delicate ecosystem. Imagine a world where the sun's rays no longer reach the Earth's surface, plunging the planet into darkness. In this alternate reality, the loss of sunlight would have a profound impact on photosynthesis in plants. Photosynthesis is a vital process that plants use to convert sunlight into energy, allowing them to grow and thrive. Without sunlight, plants would struggle to produce the energy they need to survive. Sunlight is a key ingredient in the photosynthesis process, as it provides the energy needed to power the chemical reactions that convert carbon dioxide and water into glucose and oxygen. Without sunlight, plants would not be able to carry out these reactions effectively, leading to a significant decrease in their ability to produce food and oxygen. In a world without sunlight, plants would likely undergo drastic changes in order to adapt to the new conditions. Some plants may evolve to become more efficient at capturing and using any available light, while others may develop alternative methods of obtaining energy, such as through chemosynthesis or other means. Overall, the loss of sunlight would have a devastating impact on photosynthesis and plant life as we know it. It serves as a reminder of the delicate balance of nature and the importance of sunlight in sustaining life on Earth. In a world where plants can no longer produce energy, the consequences on the food chain would be catastrophic. Plants play a crucial role as the primary producers of energy through photosynthesis, providing the foundation for the entire ecosystem. Without plants, herbivores that rely on them for food would quickly face extinction, leading to a collapse in populations of animals higher up the food chain that depend on herbivores for sustenance. Carnivores would struggle to find prey, causing a ripple effect throughout the ecosystem. Many species would be forced to adapt to new diets or face the threat of starvation. Predators higher up the food chain would be particularly vulnerable, as their food sources dwindle. The extinction of plant life would also have far-reaching effects on oxygen levels in the atmosphere. Plants are essential for converting carbon dioxide into oxygen through photosynthesis. Without this process, oxygen levels would decrease, impacting the respiratory systems of animals and humans alike. Overall, the disruption of the food chain due to the inability of plants to produce energy would lead to a domino effect of extinctions and ecosystem collapse. It serves as a stark reminder of the delicate balance that exists in nature and the interconnectedness of all living organisms. Imagine a world where the sun suddenly goes out, plunging Earth into darkness. The consequences would be catastrophic, especially when it comes to surface temperatures. Without the sun's warmth, temperatures on Earth would start to plummet almost immediately. The side of the planet facing away from the sun would rapidly cool down, leading to freezing temperatures within hours. As the Earth rotates, different regions would experience varying degrees of temperature drop, but overall, the entire planet would quickly become icy cold. The absence of sunlight means that there would be no energy to heat the atmosphere and the ground, causing a rapid and dramatic decrease in temperatures. Within days, most of the planet would be covered in ice and snow as the cold continues to intensify. Without the sun's heat, plant life would die off, leading to a cascading effect on the entire ecosystem. Animals that rely on plants for food would struggle to survive, further impacting the food chain. In this chilling scenario, humans would face an unprecedented challenge in trying to adapt to the extreme cold. The lack of sunlight would also disrupt weather patterns, leading to chaotic and unpredictable conditions. As the days pass, the Earth would become a frozen, inhospitable world where survival would be a constant struggle. The sudden extinction of the sun would mark the end of life as we know it, highlighting how vital the sun is for sustaining life on Earth. It serves as a stark reminder of the fragility of our existence and the profound impact that our sun has on our planet's climate and ecosystems. Imagine a world where the sun suddenly burnt out, plunging Earth into darkness and cold. The immediate aftermath of such an event would bring about drastic and catastrophic climate changes. With the primary source of heat and light gone, temperatures would plummet rapidly. The sudden drop in temperature would cause widespread freezing, leading to a global winter unlike anything ever experienced before. Without the sun's energy, plant life would quickly wither and die, disrupting the entire food chain. This would result in a domino effect, causing the collapse of ecosystems worldwide. The absence of sunlight would also disrupt weather patterns, leading to extreme storms and unpredictable atmospheric conditions. Additionally, the lack of sunlight would impact the planet's water cycle, potentially causing disruptions in rainfall patterns and leading to widespread droughts in some areas while others may experience heavy rainfall and flooding. The sudden climate changes would pose significant challenges for any surviving life forms, requiring quick adaptation to the new hostile environment. In summary, the immediate aftermath of the sun burning out would bring about a catastrophic global winter, disrupting ecosystems, weather patterns, and the water cycle. Life on Earth as we know it would face unprecedented challenges in the face of such a dramatic climate shift. Imagine a world where the sun suddenly dims and solar energy diminishes. The oceans, vast bodies of water that cover over 70% of the Earth's surface, would undergo drastic changes. With a decrease in solar energy, the oceans would experience a drop in temperature, leading to disruptions in weather patterns and marine life. The sudden loss of solar energy would impact the process of evaporation, which plays a crucial role in the water cycle. Evaporation helps regulate global temperatures and influences weather patterns. A decline in solar energy would result in reduced evaporation rates, potentially leading to changes in precipitation patterns and altering the distribution of freshwater resources around the world. Furthermore, marine ecosystems, which rely on sunlight for photosynthesis and energy production, would face significant challenges. Phytoplankton, the foundation of the marine food chain, would struggle to survive in lower light conditions. This could have cascading effects on marine life, disrupting entire ecosystems and leading to changes in biodiversity. The oceans play a vital role in regulating the Earth's climate, absorbing heat and carbon dioxide from the atmosphere. A sudden loss of solar energy would impact the ocean's ability to perform these functions effectively, potentially accelerating climate change and further destabilizing global weather patterns. Overall, the sudden loss of solar energy would have far-reaching consequences for the oceans, affecting marine life, weather patterns, and the Earth's climate system. Adapting to these changes would require innovative solutions and a deeper understanding of how the oceans interact with the broader environment. Exploring alternate histories and what-if scenarios can lead us to fascinating hypothetical situations, like pondering what would happen to the atmosphere if the sun were to suddenly cease providing heat. Without the sun's energy, Earth would plunge into darkness and extreme cold. The atmosphere, which relies on the sun's heat for circulation patterns and weather systems, would undergo drastic changes. The lack of solar energy would disrupt the balance of temperature differences that drive winds and ocean currents, leading to global chaos. As the sun's warmth fades, the atmosphere would rapidly cool down, causing the air to contract and become denser. This denser air would sink closer to the surface, while the upper atmosphere would become increasingly thin and cold. Without the sun's heating effect, the air would lose its ability to hold moisture, resulting in widespread condensation and the formation of thick clouds that would blanket the sky. With the absence of solar radiation, photosynthesis in plants would cease, leading to a cascade effect on the food chain and ecosystems. As plants die off, oxygen production would decline, potentially leading to a decrease in breathable air. The darkness and cold would also have profound psychological effects on living beings, disrupting circadian rhythms and triggering widespread depression and anxiety. In this hypothetical scenario, human survival would become a significant challenge. The lack of sunlight would hinder agriculture, making it nearly impossible to grow crops for food. Energy sources that rely on solar power, such as solar panels, would become useless, plunging society into darkness and energy scarcity. Overall, if the sun were to cease providing heat, the atmosphere would undergo dramatic changes, leading to a cascade of effects on Earth's climate, ecosystems, and human civilization. It serves as a stark reminder of the importance of the sun in sustaining life on our planet. Alternate histories and what-if scenarios often explore intriguing possibilities, sparking our imagination and curiosity. In considering the question of whether any form of life would survive the initial aftermath of the sun burning out, we delve into a realm of speculative science and creative conjecture. In a hypothetical scenario where the sun exhausts its nuclear fuel and transitions into a white dwarf, the consequences for life on Earth would be catastrophic. The lack of solar energy would lead to a rapid drop in temperatures, rendering the planet inhospitable for most known forms of life. However, the potential for life to endure such extreme conditions cannot be entirely ruled out. One intriguing possibility is the concept of extremophiles, organisms capable of thriving in environments considered hostile to most life forms. These resilient creatures have been found in some of the most extreme places on Earth, such as deep-sea hydrothermal vents, acidic hot springs, and polar ice caps. It is not inconceivable that some extremophiles could adapt to the harsh conditions following the sun's demise, carving out niches where they can survive and evolve. Furthermore, technological advancements in genetic engineering and bioengineering may offer a glimmer of hope for the survival of life beyond Earth's current limitations. Scientists could potentially engineer organisms with enhanced resilience to withstand the frigid temperatures and limited energy sources in a post-sun Earth. While the prospect of life persisting after the sun burns out may seem far-fetched, the resilience and adaptability of life on Earth have continually defied expectations. As we continue to explore the frontiers of science and push the boundaries of what is possible, the survival of life in the face of cosmic challenges remains a tantalizing prospect for those intrigued by alternate histories and what-if scenarios. Imagine a world where the sun suddenly goes out, plunging the Earth into darkness and cold. The news of the sun's extinction would spread like wildfire across the globe, causing panic and fear among human civilization. Scientists and experts would scramble to understand what happened and how it would impact life on Earth. People would be faced with the harsh reality of a future without sunlight, leading to widespread uncertainty and despair. Governments and organizations would work frantically to come up with solutions to survive in this new reality. As days pass and the temperature continues to drop, humanity would be forced to adapt to a world without the life-giving warmth of the sun. Energy sources would need to be quickly revamped to sustain life in the darkness. The extinction of the sun would spark a global conversation about the fragility of life and the importance of finding ways to protect our planet and ensure our survival. It would be a wake-up call for humanity to come together, innovate, and overcome the greatest challenge we have ever faced. In the realm of alternate histories and what-if scenarios, one particularly intriguing question to ponder is, what immediate actions would governments take in response to the sun burning out? Imagining such a catastrophic event can lead to a myriad of possible outcomes and strategies that leaders around the world might consider. In the face of this existential crisis, governments would likely prioritize ensuring the survival of their populations through innovative approaches and swift decision-making. Upon the realization that the sun has burned out, governments would likely initiate emergency plans to secure essential resources such as food, water, and energy. With sunlight no longer available, alternative sources of energy would become a critical focus, prompting a global shift towards sustainable technologies like nuclear fusion, geothermal energy, and advanced battery storage systems. Efforts to harness and distribute these new energy sources efficiently would be paramount to prevent widespread chaos and ensure the functioning of essential services. Furthermore, governments would need to implement measures to regulate and manage the drastic changes in climate and ecosystems resulting from the sun's disappearance. The sudden drop in temperature would necessitate the development of advanced heating technologies to keep populations warm and prevent mass freezing events. Additionally, agriculture would face significant challenges due to the lack of sunlight for photosynthesis, requiring governments to invest heavily in indoor farming methods and synthetic nutrients to sustain food production. In terms of international cooperation, governments would likely form alliances and partnerships to share resources, knowledge, and technology in a collective effort to adapt to the new reality of a sunless world. Space exploration and colonization projects might also receive renewed interest as a means of finding habitable environments beyond Earth. Diplomatic efforts would be crucial in navigating potential conflicts arising from resource scarcity and competing interests in the face of dwindling supplies. Overall, the scenario of the sun burning out presents a daunting challenge that would test the resilience, ingenuity, and cooperation of governments worldwide. The immediate actions taken in response to such a crisis would shape the future of humanity and determine our capacity to adapt to extreme circumstances beyond our current comprehension. In a world where the sun no longer existed, the implications for energy production would be enormous. With solar power no longer available, alternative energy sources would become vital for sustaining life on Earth. Scientists and engineers would need to explore new technologies and solutions to meet the energy needs of the global population. One potential source of energy in this scenario could be nuclear fusion. While still in the experimental stages, nuclear fusion has the potential to generate vast amounts of clean energy without relying on the sun. Governments and research institutions would likely invest heavily in developing fusion technology to replace the lost solar energy. Another option could be harnessing geothermal energy. By tapping into the Earth's natural heat reservoirs, it would be possible to generate electricity and heat for various purposes. Geothermal power plants could become more widespread as a reliable source of energy in the absence of solar power. Wind and hydroelectric power would also play a significant role in the new energy landscape. Wind turbines could be installed in strategic locations to capture the power of the wind, while hydroelectric dams could continue to generate electricity using the force of flowing water. These renewable energy sources would help fill the gap left by the absence of solar energy. Moreover, advancements in energy storage technology would be crucial in a sunless world. Batteries and other storage solutions would need to become more efficient and cost-effective to store energy generated from alternative sources for use during periods of low production. Overall, the disappearance of the sun would prompt a fundamental shift in how we produce and consume energy. It would require innovation, collaboration, and a collective effort to adapt to this new reality and ensure a sustainable energy future for humanity. In this alternate history scenario, where the world is plunged into darkness due to a catastrophic event, it sparks a wave of innovation and technological advancements aimed at coping with the challenges of this new dark world. One key technology that might be developed is advanced solar-powered lighting solutions. Scientists and engineers could work on creating highly efficient solar panels and energy storage systems to harness and store solar energy during the daytime, providing a sustainable source of light during the night. Another technology that could emerge is enhanced communication systems designed to overcome the limitations of traditional methods in the absence of widespread electricity. This could involve the development of long-range radio communication devices or even advanced signal flare systems to help people stay connected and coordinate in the darkness. Furthermore, advancements in thermal imaging technology could play a crucial role in navigating the dark world. By utilizing heat signatures to create visual representations of the environment, individuals could effectively see in the dark and avoid potential dangers. This technology could be integrated into various tools and devices, such as handheld thermal imaging cameras or even wearable goggles. Additionally, with the scarcity of traditional energy sources, there might be a push towards developing more efficient and sustainable transportation solutions. This could lead to the innovation of electric vehicles with extended battery life and rapid charging capabilities, enabling people to travel safely and efficiently in the dark world. Overall, the development of these technologies in response to the challenges of a dark world showcases human resilience and adaptability in the face of adversity. By embracing innovation and creativity, individuals in this alternate history scenario demonstrate their ability to overcome obstacles and thrive in even the most challenging environments. Imagine a world without sunlight, where darkness blankets the earth constantly. How would human behavior adapt to such a drastic change in our environment? Without sunlight, our circadian rhythms would be thrown off balance, leading to potential disruptions in sleep patterns and overall health. The absence of natural light could also impact our mental well-being, as sunlight plays a crucial role in the production of serotonin, a hormone that contributes to feelings of happiness and well-being. In a world without sunlight, humans may need to rely on artificial light sources to simulate daylight and regulate their internal body clocks. This could lead to a shift in how we structure our daily routines and activities, as well as how we design our living and working spaces to optimize artificial lighting. Furthermore, the lack of sunlight could have implications for agriculture and food production, as plants require sunlight for photosynthesis. In a sunless world, alternative methods of growing food would need to be developed to ensure the survival of human populations. Overall, the absence of sunlight would undoubtedly bring about significant changes in human behavior, requiring us to adapt and innovate in order to thrive in a world shrouded in perpetual darkness. Imagine a world where the sun's cycles, the very heartbeat of our concept of time, suddenly vanished. What if the sun no longer rose and set, casting doubt upon the very essence of day and night? In such an alternate history, humans would face a profound challenge in maintaining a sense of time without the familiar rhythm of the sun. Without the sun's daily journey across the sky, our reliance on traditional timekeeping methods such as clocks and calendars would become even more crucial. People would need to rely on artificial means to track the passage of time, turning to advanced technologies or astronomical observations to create a new system of time measurement. The absence of the sun cycles would disrupt our circadian rhythms, the internal body clock that regulates our sleep-wake cycle. Without the natural cues provided by sunlight, humans would likely struggle to maintain regular sleep patterns, leading to potential health issues and a sense of disorientation. In this hypothetical scenario, society would need to adapt rapidly to the new reality of a sunless world. Industries dependent on daylight, such as agriculture and tourism, would face significant challenges in adjusting their operations to function without natural light. Urban planning and infrastructure would also need to be reimagined to accommodate the loss of solar energy and its impact on daily life. Overall, the disappearance of the sun cycles would prompt a fundamental reevaluation of our relationship with time and the natural world. While humans possess the ingenuity to create alternative timekeeping systems, the psychological and physiological effects of living in a world without the sun's guidance would undoubtedly be profound and far-reaching. One intriguing aspect of alternate histories and what-if scenarios is exploring how changes in daylight and darkness patterns could affect mental health in different timelines. Imagine a world where darkness shrouds the land for extended periods, plunging civilizations into continuous night. In such a scenario, the human psyche would undoubtedly face significant challenges due to the absence of natural light. Prolonged darkness can disrupt our circadian rhythms, the internal clock that regulates our sleep-wake cycle. Without the cues of daylight, individuals may struggle to maintain a regular schedule, leading to sleep disturbances and potentially exacerbating conditions like insomnia and depression. Seasonal affective disorder, SAD, a type of depression linked to changes in seasons, could become a pervasive issue in a world where sunlight is a rare commodity. Furthermore, the psychological impact of constant darkness on individuals' mood and cognitive function cannot be underestimated. Sunlight plays a crucial role in the production of serotonin, a neurotransmitter that contributes to feelings of well-being and happiness. In a world devoid of natural light, serotonin levels could plummet, increasing the risk of mood disorders such as anxiety and depression. Moreover, the absence of sunlight may also hinder vitamin D production in the body, which is essential for maintaining strong bones and overall health. Vitamin D deficiency has been linked to an increased risk of depression and other mental health conditions, further highlighting the potential negative consequences of prolonged darkness on mental well-being. In such a world, individuals may need to rely on artificial light sources and innovative technologies to simulate the effects of daylight and mitigate the adverse effects of perpetual darkness on mental health. Strategies such as light therapy, where individuals are exposed to bright artificial light to mimic natural sunlight, could become essential tools in combating the psychological toll of living in a world devoid of daylight. Overall, exploring alternate histories and what-if scenarios that delve into the impact of prolonged darkness on mental health offers a thought-provoking glimpse into the intricate relationship between light, darkness, and the human mind. It serves as a reminder of the profound ways in which environmental factors can shape our psychological well-being and underscores the importance of understanding and addressing the mental health implications of altered light conditions in different timelines. Imagine a world where the polar ice caps are not influenced by solar warming. In this alternate reality, the absence of solar energy would have significant consequences on the Earth's climate and ecosystems. Without solar warming, the polar ice caps would experience a drastic cooling effect, leading to a rapid expansion of ice coverage. This would result in thicker and more extensive ice sheets at both the North and South Poles. The impact of this scenario would extend far beyond the polar regions. The cooling effect caused by the lack of solar warming would disrupt global weather patterns and ocean currents, potentially triggering extreme weather events such as prolonged cold spells and heavy snowfall in regions that are not accustomed to such conditions. This could have serious implications for agriculture, infrastructure, and human settlements worldwide. Furthermore, the changes in ice coverage would also have a profound impact on sea levels. With the polar ice caps expanding without solar warming, there would be a decrease in the amount of water melting and flowing into the oceans. This would result in a drop in sea levels over time, affecting coastal communities and marine ecosystems that rely on a delicate balance of water levels for survival. Overall, the absence of solar warming on the polar ice caps would lead to a dramatic shift in global climate patterns and ecological systems. It would challenge our understanding of Earth's delicate balance and highlight the interconnectedness of different elements in the natural world. The implications of such a scenario would be far-reaching and would require careful consideration and adaptation to navigate the challenges posed by a world without solar warming affecting the polar ice caps. Alternate histories and what-if scenarios offer fascinating glimpses into how the world could have been if certain events played out differently. Exploring these hypothetical situations encourages us to think critically about the past and consider how history might have unfolded in unexpected ways. When contemplating scenarios like these, it's important to consider the potential long-term effects on Earth's geology that could arise from significant changes in climate or environmental conditions. One intriguing aspect to ponder is the impact of cooling on Earth's geology. If the planet experienced a prolonged period of cooling due to altered climate patterns or other factors, it could lead to various geological changes over time. For instance, cooling could influence the distribution and extent of glaciers, affecting the landscape through processes like erosion and sediment deposition. Changes in temperature and precipitation could also impact the formation of landforms such as mountains, valleys, and coastal features. Furthermore, cooling could potentially influence the Earth's tectonic activity. Shifts in climate can affect the distribution of weight on the planet's crust, potentially triggering adjustments in tectonic plates and volcanic activity. These changes could have long-lasting effects on the geology of different regions, altering landscapes and geological processes in significant ways. Considering the interconnected nature of Earth's systems, it's clear that changes in climate can have far-reaching consequences for geology. Exploring the potential long-term effects of cooling on Earth's geology and alternate histories and what-if scenarios can provide valuable insights into the complex interactions between climate, geology, and the environment. By delving into these hypothetical situations, we can deepen our understanding of the dynamic processes that shape our planet and appreciate the delicate balance that exists within Earth's geological systems. Imagine a world where the sun suddenly disappears, plunging the Earth into darkness and cold. How would animals adapt to such a drastic change? In this alternate history scenario, the sudden loss of sunlight and warmth would have profound effects on the animal kingdom. With sunlight essential for photosynthesis and warmth crucial for maintaining body temperature, animals would face significant challenges in this new environment. Some species may possess adaptations that allow them to survive in darkness, such as enhanced night vision or the ability to navigate using other senses like echolocation. Creatures that rely on sunlight for energy, however, would struggle to find alternative sources of sustenance. Migration would likely become a common strategy for many animals, as they seek out regions where residual warmth and light still exist. Those that are unable to migrate may need to hibernate or enter a state of suspended animation to conserve energy until conditions improve. Predator-prey dynamics would also shift in this new world, as hunting and foraging become more difficult in the absence of sunlight. Some species may evolve new strategies for finding food, such as developing heightened senses of smell or using bioluminescence to attract prey. Overall, the sudden loss of sunlight and warmth would present a formidable challenge for animals, forcing them to adapt in creative and unexpected ways to survive in this altered environment. Exploring alternate histories and what-if scenarios can lead us to fascinating questions about the world around us. One intriguing question that often arises is whether any ecosystems would be able to survive in the dark. Imagining a world where light is scarce or entirely absent opens up a realm of possibilities for how different forms of life might adapt and thrive. In considering this question, it's important to remember that life on Earth is incredibly diverse and resilient. While many ecosystems rely on sunlight as a primary energy source through photosynthesis, there are also deep-sea ecosystems that have adapted to thrive in complete darkness. These ecosystems, found in the depths of the ocean where sunlight cannot penetrate, have developed unique ways of obtaining energy through processes like chemosynthesis, where organisms derive energy from chemical reactions rather than sunlight. If we were to envision a world where darkness prevailed on the surface, it's possible to speculate that certain underground or cave-dwelling ecosystems could continue to exist. These ecosystems, shielded from the light above, might rely on alternative energy sources such as geothermal heat or chemical reactions to sustain life. Creatures adapted to this environment could have evolved specialized sensory adaptations to navigate and thrive in the absence of light. Furthermore, considering the vastness of the universe and the possibility of exoplanets with very different conditions from Earth, it's not beyond the realm of imagination to conceive of ecosystems on other worlds that have evolved to survive in perpetual darkness. Such speculative scenarios can inspire wonder and curiosity about the potential diversity of life forms that could exist beyond our own planet. In the realm of alternate histories and what-if scenarios, the question of whether ecosystems could survive in the dark invites us to ponder the resilience and adaptability of life in the face of challenging conditions. It challenges us to rethink our assumptions about what is necessary for life to exist and thrive, opening up new avenues for exploration and discovery in the vast tapestry of possibilities that the universe holds. Imagine a world where the sun's rays no longer reach the Earth's surface as they once did, plunging the planet into darkness. In this alternate history, the loss of sunlight would have a profound impact on the migratory patterns of species across the globe. Without the sun to guide them, many animals that rely on daylight cues for navigation would face significant challenges in their journeys. Migratory birds, for example, often use the position of the sun in the sky to orient themselves during long-distance flights. Without sunlight, these birds would struggle to maintain their regular migration routes, leading to disruptions in ecosystems and potential declines in populations. Insects, too, rely on sunlight for navigation, with many species using the sun's position to guide their movements. The loss of sunlight would likely result in disruptions to insect populations and could have cascading effects throughout the food chain. Marine species that migrate based on seasonal changes in sunlight would also be impacted by the loss of this vital resource. For example, sea turtles use the angle of the sun's rays to navigate during their long migrations between feeding and nesting grounds. Without sunlight to guide them, sea turtles and other marine creatures could become disoriented, leading to increased mortality rates and disruptions to marine ecosystems. Overall, the loss of sunlight in this alternate history would have far-reaching consequences for the migratory patterns of species worldwide. Without the sun's guiding light, many animals would struggle to navigate their environments, leading to disruptions in ecosystems and potential population declines. As scientists and researchers grapple with the challenges posed by this dramatic change, the future of migratory species hangs in the balance. In a world without the sun, artificial light would become a vital lifeline for survival and progress. The absence of sunlight would plunge the planet into darkness, creating a constant need for alternative sources of light to illuminate our surroundings, provide warmth, and sustain life as we know it. Artificial light would be the key to maintaining some semblance of normalcy in a world devoid of natural light. People would rely on advanced technologies such as LED lighting, bioluminescent organisms, and other innovative light sources to simulate daylight and regulate biological rhythms. Without the sun's natural cycle to guide our days and nights, artificial light would dictate our schedules and routines, shaping how we work, socialize, and interact with our environment. Furthermore, artificial light would be crucial for agriculture and food production in a sunless world. Plants would require artificial light sources to undergo photosynthesis and grow, ensuring a stable food supply for humans and other living beings. Advanced indoor farming techniques utilizing artificial light spectrum would be developed to sustainably cultivate crops and maintain ecosystem balance in the absence of natural sunlight. Beyond practical considerations, artificial light would also have profound psychological and emotional impacts on individuals in a sunless world. The perpetual darkness would necessitate the creation of artificial daylight zones where people could experience the benefits of light therapy, combating seasonal affective disorder and maintaining mental well-being in the absence of sunlight. Overall, artificial light would play a central role in shaping every aspect of life in a world without the sun, serving as a beacon of hope and innovation in the face of unprecedented challenges. Its transformative power would illuminate our path forward, guiding us through the darkness towards a future where light, in all its forms, remains a source of comfort, inspiration, and resilience. Imagine a world where plant life has gone extinct, creating a challenge for humans to adapt their diets to survive in this new reality. With plants being a primary source of nutrition for many people, the extinction of plant life would require significant adjustments in dietary habits. In such a scenario, humans would likely turn to alternative sources of sustenance to meet their nutritional needs. One potential adaptation could involve an increased reliance on fungi as a food source. Fungi, such as mushrooms, can provide essential nutrients like protein, vitamins, and minerals. Additionally, algae could become a more prominent part of the human diet, offering a rich source of nutrients like omega-3 fatty acids and antioxidants. In the absence of plant-based foods, humans might also explore alternative protein sources such as insects. Insects are a sustainable and protein-rich food option that has been consumed in many cultures throughout history. With the extinction of plant life, insects could become a more accepted and widely consumed food source. Furthermore, with the decline of traditional agricultural practices, humans may need to adopt more innovative farming techniques to sustain themselves. Vertical farming, hydroponics, and lab-grown meat could become essential methods for producing food in a plantless world. Overall, the extinction of plant life would necessitate a significant shift in human diets and food production methods. By embracing alternative sources of nutrition and exploring new culinary possibilities, humans could adapt and thrive in a world without plants. Imagine a world where we could grow our food indoors, without relying on traditional farming methods. This concept opens up a realm of possibilities and challenges in the realm of alternate histories and what-if scenarios. The idea of indoor farming, also known as vertical farming, has gained traction in recent years due to advancements in technology and the need for sustainable food production. One way we could grow food indoors is through hydroponics, a method that involves growing plants in a nutrient-rich water solution without soil. This method allows for precise control over the plant's environment, including temperature, light, and nutrients. Hydroponics can be implemented on a small scale in homes or on a larger scale in commercial vertical farms. Another method for indoor farming is aeroponics, which involves growing plants in an air or mist environment without the use of soil or an aggregate medium. In aeroponics, plant roots are suspended in the air and are regularly misted with a nutrient solution. This method is highly efficient in terms of water usage and nutrient delivery to the plants. In addition to hydroponics and aeroponics, indoor farming can also utilize technologies such as artificial lighting, climate control systems, and automation to create optimal growing conditions for plants. These technologies can simulate natural sunlight, regulate temperature and humidity levels, and automate tasks such as watering and nutrient delivery. Overall, the ability to grow food indoors presents a promising solution to challenges such as limited arable land, climate change, and food security. By exploring alternate histories and what-if scenarios related to indoor farming, we can envision a future where food production is more sustainable, efficient, and accessible to all. Imagine a world where the global temperature fluctuates drastically over the next few weeks, months, and years. In this alternate history, the planet experiences a series of unexpected climate shifts that have profound effects on ecosystems, weather patterns, and human societies. As the weeks pass, temperatures soar to unprecedented levels in some regions while plummeting to freezing lows in others. This volatile climate leads to extreme weather events such as intense heat waves, severe storms, and prolonged periods of drought. Over the months that follow, the erratic global temperature trends continue to wreak havoc on the environment. Ice caps melt at alarming rates, causing sea levels to rise dramatically and threatening coastal communities around the world. Meanwhile, areas that were once lush and fertile now face desertification and food shortages as a result of the change in climate. The delicate balance of ecosystems is disrupted, leading to widespread extinction of plant and animal species. Years into this alternate timeline, the long-term impacts of the fluctuating global temperatures become more apparent. Rising sea levels force millions of people to flee their homes, creating a refugee crisis of unprecedented scale. Agriculture becomes increasingly challenging as traditional growing seasons no longer align with the new climate reality, leading to widespread food insecurity and economic instability. Governments and organizations scramble to find solutions to mitigate the effects of climate change, but the damage is already done. In this what-if scenario, the unpredictable nature of global temperatures has far-reaching consequences that reshape the world as we know it. As we ponder the potential outcomes of such extreme climate shifts, it serves as a stark reminder of the importance of taking action to address climate change and protect our planet for future generations. In alternate histories and what-if scenarios, the fate of renewable energy sources that depend on sunlight could vary greatly based on different factors and events. For example, imagine a world where the discovery and utilization of solar power happened much earlier in history than it did in reality. This could lead to a significant shift in the global energy landscape, with solar energy becoming the dominant source of power much earlier on. On the other hand, in a scenario where key advancements in solar technology were delayed or hindered by external factors, such as political conflicts or economic crises, the adoption of solar energy might have been slower or even stalled altogether. In a more extreme alternate history, envision a world where sunlight itself was somehow diminished or altered due to a natural disaster or cosmic event. This could have catastrophic consequences for solar power generation, as the energy output of solar panels would be significantly reduced. In such a scenario, society would need to rapidly adapt and innovate in order to find alternative sources of energy to sustain itself. Alternatively, if a breakthrough in solar technology occurred that vastly improved the efficiency and affordability of solar panels, it could lead to a revolution in renewable energy usage across the globe. This could result in a rapid transition away from fossil fuels and towards clean, sustainable energy sources, transforming the way humanity powers its cities, industries, and transportation systems. Overall, the fate of renewable energy sources that depend on sunlight in alternate histories and what-if scenarios is a fascinating and complex topic that offers endless possibilities for exploration and speculation. By considering different narratives and outcomes, we can gain valuable insights into the potential impact of historical events on the development and adoption of solar power technologies. Imagine a world where the sun suddenly disappears from the sky, plunging Earth into darkness. The loss of the sun would have a drastic impact on our planet's weather patterns. Without the sun's warmth and energy, temperatures would plummet rapidly, leading to extreme cold conditions across the globe. The lack of sunlight would disrupt the process of evaporation, causing a significant decrease in rainfall and the formation of clouds. As a result, many regions would experience prolonged droughts, leading to water shortages and desertification in once fertile areas. The absence of sunlight would also disrupt the Earth's atmospheric circulation, causing unpredictable and chaotic weather patterns. Storms and hurricanes could become more frequent and intense, as the lack of solar energy destabilizes the Earth's climate systems. Furthermore, the loss of the sun would impact plant life and agriculture, leading to widespread crop failures and food shortages. The disruption of the planet's natural balance would have far-reaching consequences for ecosystems and biodiversity, potentially leading to mass extinctions of plant and animal species. In this alternate reality without the sun, Earth would be a dark, cold, and inhospitable place, forever changed by the absence of our life-giving star. In this diverse world of alternate histories and what-if scenarios, the possibilities are endless. As we delve into these hypothetical worlds, one question that arises is whether life would have a chance of surviving in extreme environments. Imagine a reality where history took a different turn, leading to vastly different landscapes and conditions. Would organisms be able to adapt and thrive in these new, challenging settings? In these alternate worlds, we could envision scenarios where Earth's climate, geography, and even the laws of nature have evolved differently. Perhaps there are planets with scorching temperatures, toxic atmospheres, or barren landscapes. In such extreme environments, life as we know it may struggle to survive. However, nature has a remarkable ability to adapt and evolve in response to changing conditions. In these what-if scenarios, it is fascinating to speculate how life forms could potentially adapt to extreme environments. From extremophiles thriving in boiling hot springs to deep-sea creatures surviving in the crushing pressures of the ocean floor, life on Earth has already shown incredible resilience. In a world of alternate histories, we could imagine even more extraordinary adaptations and unexpected forms of life emerging to conquer hostile environments. Exploring the possibilities of life in extreme environments not only sparks our imagination but also prompts us to consider the incredible diversity and adaptability of living organisms. As we ponder these what-if scenarios, we are reminded of the endless wonders and possibilities that exist in the realm of alternate histories and what-if scenarios. In an alternate history where the sun unexpectedly burns out, the world would face an unprecedented crisis that would drastically change scientific research in all fields. With the primary source of energy and light gone, researchers and scientists would be forced to shift their focus towards finding new sources of energy to sustain life on Earth. The sudden darkness and cold temperatures would demand urgent solutions to provide warmth and light to support human survival. Astronomers and astrophysicists would work tirelessly to understand what caused the sun to burn out and explore the possibility of finding a new star or alternative celestial body to orbit. The study of other galaxies and solar systems would become crucial in search of a potential new home for humanity. The fields of space exploration and colonization would take on a new sense of urgency as scientists race against time to find a solution to the sun's disappearance. Meanwhile, physicists and engineers would collaborate to develop advanced technologies that harness alternative sources of energy such as nuclear fusion, geothermal energy, or even harnessing energy from other cosmic phenomena. The focus would shift towards creating sustainable and efficient energy solutions that can support the planet in the absence of the sun's light and heat. Biologists and environmental scientists would face the challenge of adapting life on Earth to the new conditions brought about by the sun's absence. They would explore genetic modifications and bioengineering to create organisms that can thrive in the darkness and cold, while also preserving existing ecosystems and biodiversity. Overall, the scientific community would unite in a global effort to overcome the crisis of the sun burning out, pushing the boundaries of knowledge and innovation to ensure the survival and prosperity of humanity in this new and challenging reality. Alternate histories and what-if scenarios open up a fascinating realm of possibilities, including how they could impact space programs and our exploration of the universe. Imagine a world where the space race never occurred, leaving us decades behind in our understanding of outer space. Or consider a scenario where global conflicts diverted resources away from space exploration, stalling our progress in reaching new frontiers. On the other hand, what if a breakthrough in technology accelerated our ability to travel beyond our solar system, leading to unprecedented discoveries and interactions with extraterrestrial life forms? These what-if scenarios provoke thought and curiosity about the future of space programs and our quest to unravel the mysteries of the cosmos. By exploring these alternate histories, we can gain a deeper appreciation for the importance of investing in space exploration and the boundless potential that awaits us among the stars. Imagining alternate histories and exploring what-if scenarios can provide fascinating insights into how international relations might be impacted by a global crisis of significant magnitude. In such a scenario, where the world is facing a crisis that transcends borders and affects multiple nations simultaneously, we could expect to see a wide range of responses and outcomes on the global stage. One possible outcome could be a shift in alliances and partnerships as countries come together to address the crisis. Traditional allies may find themselves working more closely with countries they previously had strained relations with, recognizing the need for international cooperation in the face of a common threat. This could lead to the formation of new alliances and the strengthening of existing ones, reshaping the geopolitical landscape in unforeseen ways. At the same time, the crisis could also exacerbate existing tensions and conflicts between nations. Competition for vital resources, disagreements over responsibility for the crisis, and differing approaches to managing the situation could all fuel geopolitical rivalries and diplomatic standoffs. This could lead to increased volatility and uncertainty in international relations, as countries navigate the complexities of a global crisis while also juggling their own national interests. Moreover, the economic fallout from the crisis could have far-reaching implications for international trade and cooperation. Disruptions to supply chains, a slowdown in global economic activity, and widespread job losses could strain international relations as countries seek to protect their own interests and navigate the challenges of a post-crisis world. This could lead to increased protectionism, trade disputes, and a re-evaluation of global economic structures and agreements. Overall, a global crisis of this magnitude would undoubtedly have profound effects on international relations, reshaping alliances, fueling tensions, and challenging countries to find common ground in the face of adversity. By exploring these what-if scenarios, we can gain valuable insights into the complexities of the global political landscape and the potential impact of crises on the world stage. In exploring alternate histories and what-if scenarios, one intriguing question arises: would humanity unite in the face of an existential threat? Imagining a world where a common enemy or catastrophic event threatens the very existence of humankind can lead to thought-provoking reflections on the potential for unity among nations and individuals. History shows us instances where countries have set aside their differences to combat shared threats, such as during World War II when Allied forces banded together against the Axis powers. However, it is also evident that divisions and conflicts persist, even in the face of global challenges like climate change and pandemics. The idea of a unifying force bringing humanity together is appealing, but the complexities of geopolitics, cultural differences, and conflicting interests present significant obstacles to achieving true unity. Nonetheless, the concept of an existential threat has the power to compel cooperation and solidarity, prompting us to consider what it would take for humanity to rise above divisions and work towards a common goal for the greater good. Imagining a world where the sun suddenly goes dark can lead to fascinating explorations of how different cultures and religions might interpret such a catastrophic event. In some cultures, the sun is seen as a symbol of life, warmth, and vitality, so its extinction could be viewed as a sign of impending doom or a cosmic shift. Religious beliefs could play a significant role in shaping interpretations as well. For example, in ancient civilizations that worshipped sun gods, the extinction of the sun might be seen as a punishment from the deity or a test of faith. In contrast, cultures with more scientific or rational worldviews might approach the event as a natural phenomenon requiring investigation and adaptation. Overall, the sun's extinction in an alternate history scenario could spark a wide range of reactions and interpretations, offering a rich tapestry of cultural and religious responses to a world plunged into darkness. In the realm of alternate histories and what-if scenarios, the role of nuclear energy in the survival of humanity holds a crucial position. Imagine a world where nuclear energy wasn't harnessed for peaceful purposes but instead led to catastrophic events. Alternatively, consider a scenario where nuclear energy was embraced as a clean, abundant source of power, shaping a more sustainable future for humanity. In a world facing environmental challenges and energy demands, nuclear energy could provide a viable solution. With its low carbon footprint and high energy output, nuclear power has the potential to reduce reliance on fossil fuels and mitigate the effects of climate change. However, the risks associated with nuclear energy, such as accidents and nuclear proliferation, cannot be overlooked. In an alternate history where nuclear energy was prioritized and developed with safety and security in mind, humanity might have achieved a more sustainable and prosperous future. Imagine a world where nuclear technology was used not only for electricity generation but also for powering vehicles, desalinating water, and even space exploration. The impact on global energy security and environmental sustainability could have been transformative. On the other hand, if nuclear energy had led to widespread disasters or conflicts, the survival of humanity could have been at stake. Chernobyl and Fukushima serve as reminders of the devastating consequences of nuclear accidents, highlighting the importance of stringent safety measures and international cooperation in the management of nuclear technology. Considering the potential benefits and risks of nuclear energy, it is evident that the decisions made in the past and present regarding its development and deployment have far-reaching implications for the survival and future of humanity in different alternate histories and what-if scenarios. The balance between harnessing the power of nuclear energy for progress while safeguarding against its potential dangers remains a critical challenge that shapes the course of our collective destiny. When exploring alternate histories and what-if scenarios, one intriguing question that arises is whether we could create artificial suns or alternative energy sources to replace the sun. While this idea may sound like something straight out of science fiction, the concept of artificial suns has actually been a topic of scientific exploration and experimentation. Scientists have been researching the possibility of creating artificial suns, known as artificial stars or stellarators, as a potential source of limitless energy. One of the most well-known projects in this realm is the International Thermonuclear Experimental Reactor, ITER, a collaborative effort involving 35 countries to build a fusion reactor that mimics the processes that power the sun. Fusion reactors like ITER aim to harness the power of nuclear fusion, the same process that fuels the sun, to generate clean and abundant energy. If successful, fusion reactors could potentially provide a sustainable and virtually limitless source of energy without the harmful byproducts associated with traditional fossil fuels. While the idea of creating artificial suns as energy sources holds great promise, it also poses significant challenges. The technology required to sustain nuclear fusion reactions at the scale necessary for practical energy production is still in development, and researchers continue to grapple with issues such as containment, energy efficiency, and cost-effectiveness. Additionally, the safety and environmental impact of artificial suns must be carefully considered to ensure that these technologies do not pose risks to human health or the planet. In the realm of alternate histories and what-if scenarios, the concept of artificial suns offers a fascinating avenue for exploration. Imagining a world powered by artificial stars opens up a plethora of possibilities for how society, technology, and the environment could evolve. From powering cities with clean energy to enabling interstellar travel, the potential applications of artificial sun technology are as vast as the universe itself. As we continue to push the boundaries of scientific discovery and innovation, the dream of creating artificial suns as alternative energy sources may one day become a reality. While there are still many hurdles to overcome, the pursuit of this ambitious goal exemplifies humanity's drive to harness the power of the cosmos for the betterment of our planet and civilization. Exploring alternate histories and what-if scenarios often leads us to contemplate the impact of major events on the course of humanity. One intriguing question that arises is how philosophical perspectives on life and existence might evolve in a post-extinction world. The concept of extinction, whether caused by a global catastrophe or other means, fundamentally alters the way we perceive our existence and the meaning we attribute to life. In a world where humanity faces extinction, philosophical perspectives are likely to shift dramatically. Traditional notions of purpose, morality, and the nature of reality may be upended as individuals grapple with the impending end of civilization. Existentialist philosophies, which focus on the individual's responsibility to create meaning in a seemingly indifferent universe, may become increasingly relevant as people confront their mortality on a global scale. Moreover, post-extinction scenarios could give rise to new philosophical movements that seek to redefine humanity's place in the cosmos. Transhumanist ideas, which advocate for the enhancement of human capabilities through technology, may gain prominence as individuals strive to transcend the limitations of their current existence. The exploration of artificial intelligence, genetic engineering, and other advanced technologies could lead to profound ethical dilemmas and philosophical inquiries about the nature of consciousness and identity. Ultimately, the prospect of extinction forces us to confront the fragility of life and the impermanence of human achievements. As we contemplate a world without us, philosophical perspectives on life and existence are likely to become more introspective and contemplative, prompting us to reconsider our values, beliefs, and aspirations in the face of impending oblivion. The post-extinction era may compel us to reevaluate what it means to be human and to find solace in the interconnectedness of all living beings, fostering a renewed appreciation for the beauty and complexity of existence. In a dark world filled with uncertainty and challenges, humanity could explore various long-term survival strategies to navigate through adversity and ensure its continuity. One such strategy could involve establishing resilient and self-sustaining communities that prioritize cooperation, resourcefulness, and adaptability. By fostering a strong sense of community and mutual support, individuals can come together to share skills, knowledge, and resources, thereby increasing their chances of survival in the face of ongoing threats. Additionally, investing in education and innovation could play a crucial role in equipping individuals with the tools and expertise needed to tackle complex problems and devise creative solutions. By encouraging a culture of continuous learning and experimentation, humanity can adapt to changing circumstances and develop new technologies and strategies to thrive in a dark world. Furthermore, fostering a deep respect for the environment and practicing sustainable living could help mitigate the impact of human activities on the planet and ensure the long-term viability of essential resources. By prioritizing conservation, renewable energy sources, and responsible consumption practices, humanity can reduce its ecological footprint and preserve the natural world for future generations. Embracing diversity and inclusivity could also be key to building a more resilient society capable of overcoming challenges in a dark world. By valuing different perspectives, experiences, and talents, communities can tap into a rich reservoir of ideas and solutions that can help navigate uncertain times and foster unity amidst diversity. Overall, by embracing cooperation, innovation, sustainability, and inclusivity, humanity can forge a path towards long-term survival in a dark world, fostering resilience, unity, and hope in the face of adversity. Alternate histories and what-if scenarios have always fascinated people, sparking imaginations and raising intriguing questions about the paths not taken in history. One such question that often arises is, would society revert to more primitive ways of living without sunlight? Imagine a world where sunlight suddenly disappears, plunging the Earth into eternal darkness. This scenario opens up a realm of possibilities, challenging our assumptions about the role of sunlight in human civilization. Without sunlight, plants would struggle to photosynthesize, leading to widespread crop failures and food shortages. This would undoubtedly have a ripple effect on the entire food chain, impacting both humans and animals. In such a world, humans would have to adapt quickly to survive. Communities might be forced to seek alternative food sources, turning to underground farming or artificial lighting to grow essential crops. Without sunlight to regulate our internal clocks, sleep patterns could be disrupted, leading to potential health issues. The lack of sunlight might also impact mental health, as many people rely on sunlight to boost their mood and energy levels. On a larger scale, industries that rely on sunlight, such as solar power, agriculture, and tourism, would face significant challenges. Governments would need to implement new policies and technologies to cope with the sudden shift in environmental conditions. This could lead to innovations in artificial lighting, energy sources, and urban planning to create habitable environments in the absence of natural light. In terms of societal structure, the loss of sunlight could potentially disrupt social norms and cultural practices. Rituals and traditions tied to the sun would need to be reimagined or replaced, as societies adapt to a world without daylight. Communication and transportation systems could also be impacted, as navigation becomes more challenging in perpetual darkness. Overall, the thought experiment of a world without sunlight raises thought-provoking questions about human resilience, adaptability, and the interconnectedness of our existence with the natural world. It challenges us to consider the fragility of our current way of life and the importance of sustainability and innovation in the face of unprecedented challenges. In a world without day and night, the concept of time would drastically change, leading to a shift in how education systems approach teaching. Schools would need to restructure their schedules and curriculum to accommodate continuous activity and learning opportunities. One adaptation could involve implementing flexible learning hours to cater to students who may prefer studying during specific times of the day. This could allow for personalized learning experiences and help students optimize their productivity. Additionally, schools might introduce innovative technologies such as artificial lighting and virtual learning platforms to simulate a sense of day and night for educational purposes. Teachers would also need to undergo training to effectively teach in a world without natural light cycles. They may need to learn new strategies for engaging students and maintaining their focus in a perpetual state of brightness. Furthermore, interdisciplinary approaches to education could become more prevalent as educators seek to contextualize learning in a world where traditional markers of time no longer apply. Overall, adapting to teaching in a world without day and night would require a fundamental reevaluation of how education is structured and delivered. Schools would need to embrace flexibility, technology, and creative teaching methods to ensure that students continue to receive a comprehensive and engaging education experience. In a sunless society, where the skies are forever covered in thick clouds and sunlight is a distant memory, the world of art and literature would undoubtedly undergo significant transformations. Artists and writers would be challenged to find new sources of inspiration and explore themes that reflect the bleak and shadowy existence of such a society. Without the warm glow of the sun to illuminate their works, painters may turn to darker color palettes and gloomy imagery to convey the sense of perpetual twilight that envelops their world. Landscapes devoid of sunlight would become common subjects, with artists experimenting with different techniques to capture the eerie beauty of a world shrouded in darkness. Similarly, writers would explore themes of isolation, despair, and resilience in a sunless society. Imagining a world where natural light is a distant memory, authors may craft stories that delve into the psychological effects of living in a perpetual state of twilight. Characters may grapple with feelings of hopelessness and uncertainty, while others may find solace in the small moments of beauty that still exist amidst the darkness. In this alternate reality, art and literature would serve as a reflection of the society's collective psyche, offering a glimpse into the struggles and triumphs of individuals navigating a world without sunlight. Creativity would be both a means of escape and a way to confront the harsh realities of life in a sunless society, providing a beacon of light in the darkness. Exploring alternate histories and what-if scenarios can lead us to ponder fascinating questions like how the loss of the sun might impact technological advancements. In a world where the sun suddenly disappears, humanity would face an unprecedented challenge that could spur incredible innovation. Without the sun's energy, traditional sources of power such as solar panels would become obsolete, prompting scientists and engineers to seek alternative solutions. One possible outcome could be a rapid acceleration in the development of advanced battery storage technology. With the need to store energy for extended periods without relying on solar power, researchers might focus on creating ultra-efficient and long-lasting batteries that could sustain entire cities during extended periods of darkness. This could lead to breakthroughs in energy storage that revolutionize how we power our world. Additionally, the loss of the sun could drive advancements in artificial lighting technologies. To compensate for the absence of natural light, scientists might engineer highly efficient and sustainable artificial light sources that mimic the sun's rays. This could result in the creation of powerful and eco-friendly lighting systems that illuminate our homes, workplaces, and cities without depleting precious resources. Furthermore, without the sun's warmth and light, agriculture would be severely impacted, leading to a greater emphasis on indoor farming techniques. This could drive innovation in controlled environment agriculture, where crops are grown under carefully controlled conditions with artificial lighting and climate control systems. Scientists and farmers might collaborate to develop cutting-edge methods that ensure food security in a sunless world. In conclusion, the loss of the sun would undoubtedly present immense challenges, but it could also inspire humanity to reach new heights of technological ingenuity. By pushing the boundaries of innovation in energy storage, artificial lighting, and agriculture, we might just find solutions that not only sustain us in a sunless world but also propel us towards a brighter future filled with possibilities. Imagine a world where the sun suddenly disappears from the sky, plunging the earth into darkness. This scenario sparks curiosity and fear among people, leading to a resurgence of superstitions and myths surrounding the sun's mysterious disappearance. Throughout history, the sun has been revered as a powerful deity in many cultures, symbolizing life, warmth, and vitality. With its sudden absence, people would naturally seek explanations rooted in folklore and superstition. Ancient legends and myths about celestial events would resurface, with tales of gods and goddesses battling in the heavens, causing eclipses and darkening the sun. Stories of apocalyptic prophecies and cosmic battles between light and darkness would capture the imagination of those searching for meaning in the sun's vanishing act. Superstitions related to eclipses and celestial phenomena would also gain traction, as people try to make sense of the unprecedented event. Some might believe that the sun's disappearance is a sign of impending doom or a punishment from the gods for humanity's wrongdoings. Others might see it as a test of faith, leading to the rise of new religious movements centered around interpreting the cosmic significance of the sun's absence. As fear and uncertainty grip the world in the wake of the sun's disappearance, people would turn to ancient traditions and rituals in an attempt to appease the gods and bring back the light. Shamanic practices, offerings to the sun deity, and elaborate ceremonies to ward off evil spirits could become commonplace as communities seek to restore balance and order to the world. In this alternate history where the sun's disappearance sparks a resurgence of superstitions and myths, the boundaries between science and belief blur as people grapple with the unknown. The once familiar and reliable source of light and warmth becomes a source of mystery and wonder, triggering a cultural and spiritual awakening as humanity confronts the power and majesty of the cosmos in a whole new light. Imagine a world where the sun suddenly disappears from the sky, plunging the earth into darkness. In this alternate reality, communication and information sharing would undergo drastic transformations. With the absence of sunlight, traditional methods of long-distance communication like radio waves, satellite signals, and even internet connectivity would be severely disrupted. The lack of solar energy would impact the functioning of electronic devices and infrastructure, causing widespread outages and communication breakdowns. In such a scenario, people would have to rely on alternative means of communication to stay connected. One possible method could involve the use of bioluminescent organisms or materials to create light signals for conveying messages over long distances. This creative adaptation to the new environment would enable communities to maintain some level of communication despite the challenges posed by the sun's disappearance. Furthermore, without the sun to provide daylight for visual communication, people would need to develop enhanced auditory and tactile communication skills. Verbal storytelling, music, and touch-based forms of communication would become more prevalent as individuals seek new ways to share information and connect with one another in the darkness. Overall, the absence of the sun would force humanity to innovate and adapt in order to overcome the communication barriers imposed by perpetual darkness. Despite the challenges, the resilience and creativity of individuals would drive the development of novel communication strategies that could potentially lead to a more interconnected and resourceful society in this alternative reality. Exploring alternate histories and what-if scenarios can often lead us down paths that challenge our understanding of the world and our place in it. In these alternative realities, we encounter different social structures, political systems, and cultural norms that may shape the mental health and social support mechanisms in unique ways. Imagine a world where the course of history took a different turn, leading to a darker and more tumultuous present. In such a reality, the importance of mental health and social support would likely be amplified as individuals grapple with the consequences of divergent historical events. The need for accessible and effective mental health services would be crucial in helping people navigate the challenges of this world. In this alternate reality, communities may develop innovative approaches to supporting mental well-being, drawing on collective resilience and solidarity to cope with the hardships they face. Peer support networks, group therapy sessions, and community-based interventions could serve as vital resources for individuals struggling with the emotional toll of living in a darkened world. Moreover, societal attitudes towards mental health would likely undergo significant shifts in response to the unique stressors of this alternate reality. Stigma surrounding mental illness may be challenged more openly as people recognize the widespread impact of trauma and adversity on individual and collective well-being. Governments and organizations would need to prioritize mental health initiatives and allocate resources to ensure that everyone has access to the support they need. In this alternative history, the concept of social support would extend beyond individual relationships to encompass broader societal structures that promote resilience and healing. Mutual aid networks, grassroots organizations, and cultural practices that foster connection and belonging would play a central role in helping individuals cope with the challenges of a darkened world. By contemplating these what-if scenarios and exploring alternate histories, we can gain valuable insights into the ways in which mental health and social support systems are shaped by the context in which they exist. These thought experiments remind us of the importance of compassion, understanding, and solidarity in navigating the complexities of our own reality and in building a more supportive and resilient world for all. In a world where the sun suddenly disappears, plunging Earth into eternal darkness and cold, the concept of space exploration takes on a whole new meaning. With the source of life and energy gone, humanity faces a stark reality: survive or perish. Without the sun, Earth's surface would quickly freeze, rendering it uninhabitable for most life forms. In this alternate reality, humans would be forced to seek refuge underground or in specially designed shelters to escape the deadly cold. The focus would shift from exploring outer space to finding ways to adapt and survive in this new, harsh environment. However, the innate curiosity and drive for discovery that have defined humanity for centuries may still persist. Even in the absence of the sun, the desire to explore the unknown, to push boundaries, and to seek answers to the mysteries of the universe could drive some to continue the quest for space exploration. In this altered reality, space exploration would take on a new significance. Instead of searching for new worlds to colonize or resources to exploit, humans may seek out alternative sources of energy and warmth to sustain life in the absence of the sun. Perhaps, in their quest for survival, humans would discover new technologies and innovations that could one day lead to the revival of space exploration in a different form. While the absence of the sun would undoubtedly change the course of human history and priorities, it is possible that the spirit of exploration and discovery would endure, guiding humanity towards a future where the boundaries of space and time may still be challenged, even in the darkest of times. Without a day-night cycle, the concept of time would be fundamentally different from what we are accustomed to. The day-night cycle is a crucial aspect of how we perceive and measure time, as it divides our days into distinct periods of light and darkness. Without this cycle, timekeeping would rely more heavily on artificial means such as clocks and calendars to track the passage of time. In a world without a day-night cycle, people's internal body clocks, known as circadian rhythms, might be disrupted. Our bodies are naturally attuned to the rising and setting of the sun, which helps regulate our sleep-wake cycles and other biological functions. Without this natural rhythm, individuals might struggle with sleep patterns and overall well-being. Furthermore, the absence of a day-night cycle could have significant implications for agriculture, wildlife, and ecosystems. Plants rely on sunlight for photosynthesis, the process by which they produce energy, so a lack of sunlight could disrupt plant growth and food production. Animals that rely on the day-night cycle for hunting, mating, and other behaviors might also face challenges in adapting to a world without this natural rhythm. In terms of society and culture, the concept of time as a linear progression might be altered without the daily markers of sunrise and sunset. People might need to rely more on technological innovations to structure their days and coordinate activities. Additionally, rituals and traditions tied to the day-night cycle, such as religious observances or seasonal celebrations, could evolve or disappear in a world where the natural cycle of light and darkness is no longer present. Overall, a world without a day-night cycle would present unique challenges and opportunities for how we perceive and measure time, impacting everything from our daily routines to our understanding of the natural world. Imagine a world where the sun, the very source of life on Earth, never returned after disappearing one day. The long-term ecological impacts of such a scenario would be catastrophic and far-reaching. Without the sun's warmth and light, the planet would quickly plunge into darkness and extreme cold. Photosynthesis, the process by which plants convert sunlight into energy, would cease to occur, leading to a collapse of the entire food chain. Plants would wither and die, causing a ripple effect on herbivores and omnivores that depend on them for sustenance. This would in turn impact carnivores at the top of the food chain, leading to widespread starvation and extinction. The oceans, too, would be greatly affected as phytoplankton, the base of the marine food chain, rely on sunlight for survival. Without sunlight, these crucial organisms would perish, leading to a domino effect on marine life. The absence of the sun would also disrupt weather patterns and climate systems on Earth. The planet's temperature would plummet rapidly, leading to ice ages in many regions. Extreme weather events such as storms, hurricanes, and tornadoes would become more frequent and intense due to the lack of solar energy to drive atmospheric processes. Furthermore, the disappearance of the sun would have profound psychological impacts on human beings and other living creatures. The loss of daylight and the constant darkness would likely lead to increased rates of depression, anxiety, and other mental health issues. Many species that rely on circadian rhythms and seasonal cues for breeding, migration, and hibernation would be thrown into chaos, further disrupting ecosystems. In conclusion, if the sun never returned, the long-term ecological impacts would be devastating, leading to mass extinctions, ecological collapse, and widespread environmental disruption. The world as we know it would be forever altered, highlighting the critical importance of our sun in sustaining life on Earth. Imagine a world where the sun's light dims, casting a shadow of uncertainty over our planet. Could we ever find a way to reignite or replace the sun through technology? This question sparks a fascinating exploration into alternate histories and what-if scenarios that captivates the imagination of those curious about the possibilities of our future. While the idea of replacing the sun may seem like something out of science fiction, advancements in technology continually push the boundaries of what we once thought impossible. Scientists have long been researching ways to harness the power of nuclear fusion, a process that replicates the sun's energy production here on Earth. If this technology were to be successfully developed on a large scale, it could potentially provide an alternative source of energy to sustain life on our planet. Additionally, the concept of building a Dyson sphere, a megastructure that surrounds a star to capture its energy, is another intriguing possibility that could one day be explored. While these ideas may currently reside in the realm of speculation, the pursuit of such innovations highlights the boundless creativity and ingenuity of human civilization. As we ponder the question of reigniting or replacing the sun through technology, we are reminded of the vast potential for discovery and innovation that lies ahead, shaping the course of our shared future in ways we have yet to imagine. Humanity has always been fascinated by the idea of alternate histories and what-if scenarios. One such scenario that sparks curiosity is imagining a world where the sun burns out permanently. The implications of such an event would be monumental and would leave a lasting legacy on Earth. Without the sun's warmth and light, the planet would plunge into darkness and extreme cold. Plants would die, leading to a collapse of the food chain and ultimately the extinction of most life forms. Human civilization, with all its achievements and creations, would fade into obscurity as the struggle for survival becomes the primary focus. However, even in the face of such a catastrophic event, humanity's legacy would endure in various ways. The remnants of our existence, from ancient artifacts to modern infrastructure, would serve as a testament to our once thriving civilization. Future beings, if any, might stumble upon these remnants and piece together the story of humanity's rise and fall. Moreover, the ideas and knowledge we have accumulated over centuries would not vanish completely. The collective wisdom of humanity, preserved in books, digital archives, and other mediums, could serve as a beacon of hope and inspiration for any survivors or future intelligent beings that may arise. In the end, the legacy of humanity in a world without a sun would be one of resilience, creativity, and the enduring quest for knowledge and understanding. Despite facing the ultimate challenge of survival, our mark on the universe would live on as a reminder of what we once were and what we could have become. In the realm of alternate histories and what-if scenarios, one of the most intriguing possibilities to ponder is the hypothetical scenario of the sun burning out. This cataclysmic event would have profound implications across multiple facets of life, science, society, and philosophy. Imagine a world plunged into darkness as the primary source of light and heat in our solar system fades away. How would humanity adapt to such a dire situation? From a scientific perspective, the sun burning out would challenge our understanding of physics, astronomy, and the fundamental laws that govern the universe. Scientists would need to explore alternative sources of energy to sustain life on Earth and potentially even consider the feasibility of interstellar travel to find a new habitable planet. The study of astrophysics and cosmology would take on a new urgency as researchers grapple with the implications of a sunless universe. Societal structures would undergo drastic transformations as economies collapse, governments struggle to maintain order, and communities face the stark reality of a world without sunlight. The concept of time itself would be redefined in a world where the cycles of day and night no longer exist. How would cultures and traditions evolve in a perpetual state of darkness? Would new forms of art, music, and storytelling emerge to cope with the existential challenges of a sunless world? Philosophers would wrestle with profound questions about the nature of existence, the meaning of life, and the limits of human knowledge in the face of such a monumental catastrophe. Would religious beliefs be strengthened or shattered in a world where the sun, once worshipped as a deity in many ancient cultures, has been extinguished? How would individuals find purpose and solace in a reality devoid of the familiar rhythms of day and night? As we delve into the intricacies of this thought experiment, we are compelled to contemplate the resilience of the human spirit, the boundless depths of scientific inquiry, and the enduring mysteries of the cosmos. The scenario of the sun burning out serves as a poignant reminder of our interconnectedness with the universe and the fragility of life on our pale blue dot in the vast expanse of space.